Yesterday was the 6th of December. Today is the 7th. And December is the 12th month of the year, which is 21 backwards. And I haven't even got on about 69,420 yet. Join in on a coded adventure of meme numbers, including the ones I just mentioned, along with another few secret numbers that I will only disclose when I am done with the first few. Comment your guesses below. First up, we have 21, the minimum age for someone to legally accompany a learner driver, and the maximum total value of blackjack hands until bust. But more importantly, you stupid! No, I'm not. What's 9 plus 10? 21? You stupid! Yes, the famous 9 plus 10 equals 21 meme. Originally posted on the video platform Vine, this meme was started in June 2013 by the user Drehupumsu, shot up in terms of popularity, and drew particular attention to the date 9/10/21. October 9th of 2021, or for you Americans out there, September 10th, one day before the 20th 9/11 anniversary. Dun dun dun! That's enough waffling on the details of the number, let's get coding! So the first thing, of course, is to import all functions and classes from the module turtle, and import the square root function from the module math. Then we are going to configure the function to configure the position of the turtle to draw the next digit after finishing the current digit. You will see why I used forward n times 2 in a minute. Next, we are going to define a function to draw a digit-wide horizontal line starting and finishing at the midpoint. It's a bit like the horizontal bar at the bottom of the number 1 and 2. Now that I've defined the mini functions, set up the variables, created a list called functions, which I'm going to leave empty for now, and numbers, which will take the length of the functions, store the length of the functions. Basically store some constants in variables so that the program doesn't have to spend time repeating the same function, repeating and running the same function over and over again, whereas storing data in a variable means it could instantly retrieve the required number from memory, which saves maybe a few milliseconds. Doesn't save much time, but it's just memory efficient. Our font is going to be 50 pixels. So when I say font, it's going to be, if font is 50 pixels, the final numbers will be 100 pixels wide. Basically, whatever number is stored in font, there will be 2 times that number of pixels in the number's width. This operation will require the turtle to be hidden. It just looks neater. And we need the speed to be 0 for the turtle to run as fast as possible. And optionally, you could use, if you wanted to run instantly, you could use tracer 0 to run the program. And once a turtle has finished running, you could do update, which is a turtle.screen command. But I'm not going to do tracer 0 for this project. Now we are going to define the functions to draw number 1 and number 2. We will call these functions n1 and n2. First, let's define number 1. We begin by drawing a horizontal line at the bottom of the digit to represent the horizontal bar underneath the main vertical stroke. These two commands draw the vertical stroke. Now we are turning left 135 degrees to draw to draw the serif of the number 1. We have now drawn the serif. The remaining commands will backtrack the turtle back to its original starting position, ready to transfer itself to the next digit. The turtle is now ready. The turtle is now ready to execute the next number. We are now going to define how to draw the number 2. Again, we are going to start with a horizontal bar underneath. We have now drawn the slopey bit of the number 2 that connects the bottom bar to the top circle. And we are going to draw another segment, the second straight segment that connects the slopey segment to the straight segment, and then to the top circle. We have now drawn the straight short segment. We are now going to draw the circular curve of the number 2. Note that I could have used go to skip all these commands, but this won't work if the number is rotated 90 degrees. If I try to draw the number to its side, because then otherwise it will still think that it's upright, and then it will just break the number. It just won't work. So I'm not going to use go to here, so that it is rotation, so that the number is rotationally friendly. Now we are going to see how the functions are drawn. Input the functions in the order that they are meant to be run. Here we are going to draw the number 2 first, and then the number 1 to the right of number 2. We are going to use the done command so that the window stays open once the turtle has finished running. Take the pen off the page and get the turtle ready to draw the whole numbers. -1. This is a formula to determine at what point from the back, at what point to go to how many pixels to go back, so that the numbers will be positioned at the center of the screen. Basically, there's going to be a 10% a gap between numbers, which is 10%, which has a size that is 10% the size of the font, and because the numbers are drawn from the center, if there's only one number, we don't need to go back at all. But if there is 2 numbers, we need to go back half a length. We need to go back half a number length plus half a length of the gap. And if there's 3 numbers, we need to go a full number length and a full gap length. And hence this formula arises. I'll let you work it out. Width is going to be 3 because it's just going to look nice. Put the pen down so that, because we're done with configuring, we want to draw now. For IM functions, by the way, you can actually store you could actually store function names within lists. It honestly works. Like, as long as you're not actually calling it, that's where the code within the function runs. But the object themselves can be stored as function. Sorry, not the objects. The methods themselves can be stored within lists because they're actually official data types. Unbelievably, this works because this is a function name that represents n2 and then n1. Unbelievably, this is how you iterate. This is a method that how you iterate different function names without having to like copy paste like n1 next digit, n2 next digit, and so on and so forth. But let's see what we have now. We have the number 21. Perfect. That was actually very quick and easy. Now, I have heard that if you take away 21 from the square of 21, you get 420. This is our second meme number, and it's a reference to drugs, specifically marijuana, cannabis, weed, whatever you want to call it. Before I talk myself into trouble, let's stick with draw the number out. We have already defined how to draw the number 2. We just need to define the numbers 4 and 0. Let's pre-write the numbers into the function list, and then we're going to define how to draw the number 0. Simply, we're going to do 90-degree curve for bar 90-degree curve, and then repeat the process again. So basically draw a half 0 and then draw a second half 0 to create a full 0. In range 2, which is how you draw a quarter circle using turtle. So that it is 1.8 times by n pixels tall. And we're all done for n0. It was just as simple as that. Now we're going to draw the number 4, which is going to be less simple, as opposed to 0. But still, here we are just going to take advantage of the function next digit to our own will, just so that we can move the turtle forward by half n. So it's three quarters of the way to the end. Turning left, and we're getting ready to draw the vertical bar. So the vertical stroke. Now we're drawing the top left stroke that connects our horizontal and vertical strokes. Due to trigonometry, the diagonal stroke is 3 times n. Amazing, eh? Because it's a 30-60 triangle, the sides of the triangle would follow 1, root 3, and 2. So the shortest side would be 1.5 times n, which is coincidentally what we have done using this function. And then the longest side will be 3 times n, which means that which is actually serves as a nice coincidence. Now we're going to draw the horizontal stroke. Basically, what we are going to do here is a bit of trigonometry. We have calculated the length between the horizontal stroke and the bottom of the number. Which is the height of the number minus, well, the other side of the triangle, the 30, 60, 90 degree triangle, which I've explained to you is n times 3 times root 3 over 2. Simple trigonometry. Again, taking advantage of the predetermined function to reverse the position and deconfigure the turtle and end up at the bottom center of the digit. We have now finished defining the number 4. Let's see what this looks like. Oh wow, this actually looks like a 420. That's great. Now there's many times where I have seen 420. Now there's many times where I have seen 420 being paired with one other number, resulting in the most frequent meme number pair, and that is 69. Yep, 69 420 is actually a very famous 5-digit number. I've just explained 420, but 69 is a sex position. Yep, the infamous oral sex act. The numbers represent the two bodies, each respective round circle depicted a head, and the extensions represented the body. That's it, no more. All we need to do is to define how to draw a 6, and then we can use the function for 6 to then draw a 9. Then to define 9. Alright. So we're going to use the variable head to store the length of the extension line. It's going to be n times 18 over 5 minus n times 3 over 2 times 2 over root 3. If you're wondering, this is a length of the, so this is a height of the number minus the distance between the end of the extension, the bottom end of the extension, and the bottom of the whole number, multiplied by the reciprocal of root 3 over 2. So that we get a length that's to an incline of 30 degrees. And so that it will reach the height, and so that we're sure that the height of the number as a whole will be n times 18 over 5. Now we are going to draw the circle itself. Going around a full circle, along with an extra 240 degrees. Now the forward head, it has drawn the whole number, and now we're backtracking. Now we are back at the original position. So with the progress with the circle, we have done 2 full laps, and now we are facing east again. So we finished defining N6. Now we define N9. So basically what we want to do is to have the turtle, instead of start from the bottom of the number, get to the top of the number, and then face in the opposite direction, and then execute function number 6. Left, I know I could just do go to and set headed, but that would not be rotation friendly. We've drawn N6, now we just need to backtrack. N times minus 3.6. Right, so we finished drawing 6 and 9. Let's see what this looks like. N6, N9. One mistake before we actually run. I've written 180 here when it's supposed to be 90. Because then it's just going to flip to its opposite direction rather than draw vertically upwards. And there we go. We have 69. Now I've got a bonus animation for you. We will make the two numbers spin around the center to represent sex. Let's go, baby! So what we're going to do is to create a while true loop. And we're going to include tracer 0 along with screen.update. Yep. In fact, so what we're going to do is to run the whole configuration again. But this time we're going to create an offset with the turtle, so that it actually centered, so the whole number is centered at the center of the whole number, rather than horizontally offset from the center, which is half. Font times 1.8 is half the height of the number. Basically, we're just going to copy paste. Zero. Here we're gonna get ready for the turtle to. Basically, what we're doing is we're just drawing the frames and only showing the frame off when we run update, so that we create the illusion of it spinning, whereas behind the scenes it's actually doing lots and lots of drawing, which frankly we don't want to see because it's just going to ruin the animation. But now we should have a spin in 69. This is what the spin in 69 looks like. In fact, this animation is so cool that I should show it to my next door neighbor. If I live in the house 69 and it is coincidentally the end of the road, meaning there is no house 71, I'll give you 5 seconds to work out her house number. Done, 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 ding! Yep. 67, 67, 67. 67 or 67, the currently trending meme of 2025. This number originates from a song called Doot Doot by Skrilla, released in late 2024, and was made popularized by two people. First, Taylor T.K. Kinney, a basketball player, most notably rating a Starbucks coffee 6'7". Second, Maverick Trevelyan, known as a 6'7" kid, makes numerous posts on TikTok popularizing the meme. Also 200 over 3 to the nearest integer. We don't need the while true loop anymore because this was used for the previous animation, which we are not going to execute for 6'7". I've commented it out using triple quotes, which is not a conventional way of doing it because it's not officially a comment, but rather a de facto comment, because even though it's officially a string, it has no instructional effect on the code, and so it serves the purpose of the comment. We are going to now define how to draw the number 7. Take advantage of the function next digit rather. Not like that. In unconventional ways, like that. And we're going to create something called a checkpoint. because this is where I want the turtle to end up at, because we're currently at the bottom. We're currently at the required coordinates for the bottom, where the stroke that's going towards the bottom of the number is ending, which is our destination point, which is where we're creating a checkpoint right now. Let's execute next digit again. Up, left, 90. We're basically at the bottom left corner right now. And after forward, we're going to be at the top left corner of the number 7. Right, we're ready to draw. Forward, n times 2. We've basically drawn the top half. And then go to check x, check y. And now we're back to the bottom. And then... And we're done drawing the number 7. It was simple as that. Now we're going to draw the dash. In fact, I'm going to do something unconventional again. N times... I think it's 0.9 this time. Yep, because next digit is going to move forward by double the input. Here we want to go halfway up the height of the number of the what would be a digit, and so we need the quarter of the multiplier, and basically the dash is a horizontal line. Yep, and we're back to square one again, ready to draw the next digit. Let's see how this looks. We're going to start with 6, 7 without the dash. That's perfect. And we're going to draw the 6, 7 with the dash. Also perfect. I'm impressed. Now, this number has made a certain aircraft type famous. Manufactured by Boeing, it is, wait for it, 3, 2, 1, the 767. The aircraft model that was involved in the worst aviation disaster in history, 9/11. More specifically, the towers. Both towers were taken down by 767s, and 2 other 757s crashed the same day. One in the Pentagon, another in a field near Shanksville, Pennsylvania. Before we go into drawing the number, do this to the channel to pay respects for the 2,977 victims of 9/11. I'll show you what I mean by this number when I'm done. All we need to do now is to define how to draw a slash, because we've already defined how to draw the numbers 1 and 9. The number 1 in 21 and the 9 in 69. So we're going to take advantage of the next digit function again. And we're going to use a checkpoint method again to make it rotation friendly. Next digit and 1.8. No, sorry, times 1.8. And then... Whoops. And then... And then... As easy as that. Now let's see what 9/11 looks like. That's not what I'm... Slight correction. I've seemed to have messed up one part of the video. Yep. It's here. I was not meant to have halved this number. There should have been a half, because half would only take it to halfway, the halfway point, whereas next digit n would take it from the beginning, from top left to top right, the full length, as opposed to top middle. Let's see what we have now. We have a perfect slash now, and this looks very nice. Seems like the slash has done its job. Congratulations if you've correctly guessed that this number means subscribe in Leet speak, or 1337 speak. 1337 translates into Leet, which is a special language. It's like normal English, but letters are replaced with numbers and symbols that resemble the original letter, such as 5 for S, 4 for A, and 7 for T. There are also many Leet variations of the same letter, such as 8, 13, or simply vertical bar 3 to represent B. We only need to define the number 3 to draw the number 1337, because we've defined 1 when drawing 21, and we've defined 7 when drawing 67. We're basically drawing 2 3/4 circles with this number. We're not going to do that. We go to first draw a clockwise circle in the clockwise direction, and then go back anti-clockwise direction, and because we're facing westwards at this point, we're going to extend the middle stroke so that it just sticks longer, and so that it just looks neater. And yes, the top arc is going to have a slightly shorter radius, so we're going to multiply that by 4/5. In fact, also reverse the direction. Minus 4/5, and in fact we also go to as in reverse direction, as in which way it's going. Which way it's going around the circle. Here we're just saying which side it's going. So for the initial variable, if this is negative, it affects which side it's going to go. Like if it's going to go to the left or to the right. And here, this variable depicts which way it's going to go, as in backwards or forwards. So now we've defined the number 3. We're going to run the code that's going to draw the numbers. Let's go. And boom, we have 1337. Impressive. A notable variation of Leet is upside down Leet, where the characters are flipped upside down. For example, 531-8008 and 5537-8008 translate to boobies and boobless respectively, both referring to the breasts of women. The two numbers that we have yet to define that will be necessary to draw these two numbers will be 5 and 8. We start with defining the number 5. First, we need to draw a circle n minus 90, much like in a similar fashion to how we drew the initial bottom arc for the number 3. As we have done with the number 3, we're now going to move forward so that we reach the left middle of the middle left of the number. We're at middle left now, and we need to turn right by 90 degrees. Forward. So we're now at the top of the number. Forward. Now we're facing right, and we need to go to the top right corner. We're at the top right corner now. So we go to backtrack. We're not going to backtrack, we're going to go straight down. Yep. Now we're facing eastwards again, and we're going to use the back command to go back to the bottom middle, which is a starting point. Let's actually try to draw all the numbers. So we're going to start off with 5318008. Okay, let's run. Oh, I just defined the number 8. Right. Let's do that then. We are going to do circle. Circle. Sorry, no, not. Yeah, 540. In fact, negative n times 4 over 5, 360, and then circle n and 180. Now we've defined the number 8. So basically, we've just went a full circle and a half, and then we go to do another circle, a full circle, and then to end up where we started with, and complete the second full lap of the first circle to end up where we've started with. Number 8 was actually very easy, unbelievably. In fact, that's actually a waste of time. We don't need to do that. We could just do straight away, go 180, a half circle, and then a full circle, and then complete the circle. There we go. Now let's run. Neat. Now let's do 55378008. Neat. Well, that's fantastic. Then, saving the best for last, we've got 47. Yes, the OG number, featured in the AK-47, but more significantly, it was mentioned by a certain teacher to be a funny number in response to 69 be framed as funny. This then led his students to signify the number 47. Enough for it to gain a place in the video here. Just for you, mates! Because we've already defined all of the numbers, drawing 47 will be quick and easy. Simply put N4 and N7 in the functions list and we're done. Boom. Easy as that. The final quantity of meme numbers that I have gone through after taking 2 away is, wait for it, 6 or 7. But if you add the 2 back, you get 7, 8, 9. But this makes 10 afraid. Why? Because it was in the middle of 9/11. What an end to a fantastic season and to the Big 25. Now, make this ending better by subscribing to this channel. Now, guess why the numbers in this end screen are special? Post your guesses in the comments section below. And guess which video this is a sequel to. It's one of my old videos. Now, have a Merry Christmas and a Happy New Year.